An Internet for the Solar System, extending connectivity beyond Earth. The European Space Agency, ESA, is at the forefront of a groundbreaking initiative to extend the Internet beyond Earth, paving the way for a solar system-wide network. This ambitious project, known as the Solar System Internet, SSI, aims to revolutionize space communications and support humanity's future missions in deep space. In May 2024, ESA commissioned a specialized study to define the concept of SSI, a strategic investigation into creating a robust and operational-ready network for the solar system. The study was conducted by a German-led consortium comprising GMV, Nova Space, and D3TN, each contributing expertise in project management, strategic analysis, protocol evaluation, and governance. Felix Flentger, leading ESA's SSI efforts, explains the vision. ESA is committed to establishing the Solar System Internet, an advanced network for deep space radio frequency and optical communication, as well as positioning, navigation, and timing, PNT, services. Technical challenges and solutions. The SSI faces unique challenges due to the differences between terrestrial and space environments. Terrestrial Internet protocols rely on bidirectional paths, low latency, minimal error rates, and steady network topologies. However, the SSI must be designed to accommodate dynamic topologies, high latency, increased error rates, and energy and bandwidth constraints. To address these challenges, the consortium identified three key technology pillars. Disruption-tolerant networking, DTN forms the backbone of the SSI concept, enabling reliable data transfer across disrupted and delay-prone environments using a store-and-forward mechanism. ESA has already demonstrated DTN capabilities through successful international collaborations, including the Lunar IceCube DTN demonstration. Optical communications. Optical communications are essential for high data rate communications in deep space missions. Recent demonstrations have shown remarkable potential, with NASA's Psyche mission successfully transmitting data at 25 megabits per second from 226 million kilometers, and the LADEE mission achieving 622 megabits per second data communication from the Moon. Positioning, navigation, and timing, PNT, services. PNT services for deep space will require highly autonomous space-based orbit determination and time synchronization, ODTS, technologies and long-range optical and radio frequency ranging capabilities. Building on existing capabilities. The SSI builds upon ESA's existing capabilities, including the ESTRAC core network with 435-meter deep space stations, which provides communication services across the entire solar system. The Mars Relay Network, coordinated through the European Relay Coordination Center, ERCO, is already the first operational interplanetary network. Key projects and initiatives. Moonlight. This project will become Europe's first off-planet telecommunications and navigation provider, offering lunar communications and navigation services through a constellation of 5 satellites in elliptical lunar frozen orbits. HYDRON. HYDRON is developing a high-throughput optical space network with terabit per second capacity, orders of magnitude greater than today's systems. Marconi. The Mars communication and navigation infrastructure will provide a communication and PNT service for Mars, gradually built using the Lightship propulsion tug, with an intended 6-node constellation by the 2040s. ASSIGN program. ASSIGN, Advancing Solar System Internet and Ground, is a multi-directorate program safeguarding Europe's role and interests in the global vision of the Solar System Internet. The preparatory phase, planned for 2026 to 2028, will include Phase 0, a SSI system architecture studies, covering user requirements, network architecture trade-offs, and operations concepts. Technology de-risking will address critical technologies in optical communication, DTN, and PNT. An SSI enabler component will support industrial operational capabilities and establish an SSI reference facility. A key component of ASSIGN will be the further definition of the SSI Node 1 Pathfinder mission, already studied in ESA's concurrent design facility. This ambitious smallsat mission aims to be the first to demonstrate reliable routine operations of a CIS lunar optical trunk link and the first ESA mission to use disruption-tolerant networking operationally. As humanity expands its presence beyond Earth, reliable communication networks and autonomous navigation capabilities will be essential. ESA's systematic approach to developing the solar system internet based on interoperable standards ensures that European capabilities will be integral to humanity's interplanetary future, with European companies playing a leading role.